photographic. It was at the LACMA. And then the second layer was actually recreated by a Tibetan monk in the Nano Lab, which I was very happy about. And you'll see a video of that too. So that brings me to the next phase of our collaboration. And this was also another example of how interesting it is for an artist and scientist to work together. He is very experimental, and he decided to look at the cellular structure. So this was a yeast cell in water, but he used really the atomic force microscope, which is normally not needed for a cellular level. But he was curious. And what he found is this here, like movement of the cells, totally excited him. And he wanted to send this to me, but he realized that if he sends me this, it would be meaningless, like to me. He would be excited, and I would say, I'm happy for you, that's great. Great, good, you did that. So he asked his student, Andrew Pelling, he was his PhD student at the time, now he's a professor in Ontario, who also did music on the side. He said, it's data, you know, why don't you just output it as sound? She's a media artist, she's gonna love that. And sure enough, they sent me the file that's like the cell movement that was sped up and amplified so you could hear it. So you could hear the cell movement. That's amazing. So, yes, he totally impressed me. I was like, oh my God, it's amazing. Not only was I impressed, but scientists were really curious about it. New Age people clamoring, thinking about what's going on. You can hear cells. And some work came out of that. I'll show you later. That came to the next thing where he was in his office and he never answers his phone. Always his assistant deals with his phones. But he happened to pick up the phone, and on the other line was a woman who said, I read your article about the cells and the sounds of cells, and did you ever think of measuring the sound of Chrysalis to a butterfly? It's like, no. It's like, I haven't thought about that. She's like, oh, what if I send you some chrysalises, would you measure it? And I said, yeah, send it. So then he calls me and he's like, this woman wants to work with butterflies and cells. Are you interested? And I'm like, no, I'm not actually, because I'm an artist, I'm going to work with butterflies. And he's like, but I'm not interested in it either. Okay, fine. We're in the lab. He's calling me and he goes, you have to come to the lab. All these butterflies hatched. So his lab was full of butterflies. And he goes, you got to do something. You're an artist. And I was like semi-insulted, like because it's butterflies, I'm supposed to do something here. So I'm like, okay, well, let's look at the wings. And then I thought, blue morph, I mean, they're pretty amazing. These are blue morpho butterflies, have no pigment. This is all nano-optics. So it's our eyes seeing this blue. And in the jungle, you can see them from a mile away. They're just like the most spectacular blue color. So that became fascinating, and we did some imaging. And then, you know, so what? So we tried to do the measuring of the vibrations of the chrysalis. It was very difficult because Chrysalis is so huge. So he's the kind of scientist that doesn't give up, and you know, even though both of us didn't really care, we're just kind of curious. What he finally figured out is on the chrysalis he put a very small mirror, and then he was bombarding the mirror with lasers and measuring the movement that way. Of course, he would kill the chrysalis eventually, but he would get enough of it to actually figure out how long it would take for it to keep evolving. And what came out of it actually really, we both just took a deep breath, because it just is a constant set of bursts. In other words, when we imagine change, or when we talk about how change happens, we kind of imagine gradual change. it's never gradual. From the start to end, it's like whoop, and then it's resting, kind of vibrating, and then whoop again. And it keeps doing that. And it's just incredible. And the sound, when it was amplified, so we did the same thing. We sped it up and amplified it, like with the cells. When you do that, the sound was just really incredible. And so I started thinking, how can we do something really interesting to have people experience the sound of metamorphosis? And then this was happening in 2008 when Wall Street was crashing. So I thought, it's just like Wall Street. Like we're metamorphosizing collectively with these big shifts, right? So this becomes kind of a metaphor of that. Of course, he's laughing at me while I'm saying that, but I have the freedom to do that. These are some of the images that he did in this great lab in Oregon. So they're very high resolution images. These are actually cellular images of the wing, of the blue morpho wing. And that's another close-up of it. Here's another close-up. And then this is what finally I came up with, the first iteration of it. So the idea I had was that you stand in the middle here, and or sit, as is the case with this guy. You have a 16-foot meteorological balloon, and you put on your head so you become kind of like a chrysalis, and then the sound and the blue color starts kind of pumping, and the audience gets to experience that. So we had, I'll show you videos of it, but let me just say that that piece was shown all over the world, and once people are in that sound, that you can't get them out. It's very mesmerizing. Next person I want to talk about is Mark Cohen. He's a neuroscientist, and we've been collaborating now for 4 years. Absolutely brilliant and really just completely open mind. He is famous for coming up with this experiment in the 80s, which probably wouldn't be permitted now. He had these helmets devised where your whole world would be upside down. And he had this group of people where for 24/7 for 2 weeks, they were walking around, showering, sleeping with their world upside down. What happened at a certain point is the brain flipped it, right? It just flipped the world, and they suddenly saw it normally. And so that was just amazing. A year passed, and he gave the helmets to the same people, put it on, flip. So it shows about how the brain learns and how it kind of adjusts to reality.
So the second time around, did it flip faster?
Immediately.
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 Did they find any difference between male and female brains?
I don't think so. I actually talked to him about that in another context, but I don't think so. Not in this case. So back to Bucky. When I went to his lab, the first thing that I encountered was this kind of for the Eegees, the net that you put on your head, and this device that again is totally looking like a Bucky project. Each one of these here is a camera, and you're supposed to sit down here. This is a seat, and you're inside of here, and it's registering your brain. And then this is the Hydrocele geodesic sensor net, right? So it's just completely Bucky coming back, and I just thought this is pretty amazing. So we started a project that I didn't think he would take seriously, but he agreed to it. I said, this was about 3 years ago when the whole Egypt uprising was happening, the Arab Spring. And there was a sequence of events that continue, by the way. Extreme weather patterns and extreme human kind of happenings. So I said, well, can we brainstorm about whether there's a relationship between weather patterns and human collective behavior? And he said, yes, let's do it. I want to be in a group and we can just talk about this, and I want to brainstorm with brain scientists. And he said yes. The reason he really was actually very interested in this is because he can never do this in a lab. In other words, you can do it with one person, then you have the human subject committee, and then you go through all of that, and it's very controlled and isolated. And this is more in a kind of environment like this, where it's the natural environment, you're not taken out of your context, and it's a group of people. And I'm actually very interested in group consciousness and not just isolating one person. So that's Mark there, and this is David Familian, who's the director of the Beale Gallery at UC Irvine, who invited us actually to do this as a new project. And this is the helmet that I mentioned earlier. So there's a somniferalia. We did a few, and recently we got a grant to continue with it because it actually was very successful, even without the Eegees completely working. And I'll come back to that. I just wanted to bring this in because in parallel to that, I got a commission to do something at the Santa Monica Pier. And I've always wanted to do something with the big Ferris wheel. So when they asked me to do something, I said, can I do something with the Ferris wheel? And Mark Pally, the curator, he said, yeah, you got it. And then I went home and I went, oh my God, what did I do? What am I going to do with the Ferris wheel? It's, it's already such an icon. So what I came up with is creating these 8 octopus crowns, and people would put on the crowns and go into 8 spots in the wheel, and then they would yell or chant or make wishes, and you could see them from a distance. And the idea is that basically the octopus is a biological mandala that's taking over the industrial, the wheel mandala. That was my idea, but it was anyhow fun, and I'm very successful. But I bring it up because I ended up using these guys with the Mark Cohen brainstorming right here. So once that was done, I was left with all these octopus crowns, and at one point I thought, maybe we can figure out a way where 2 people can sit across each other and try to synchronize their brain waves so they synchronize the color. And that's really what we're working on now. It's an amazing experience to do that. This is the second iteration. These guys are not completely in sync. This is Jim Jetski's research where he, independent of Mark Cohen, is trying to create a brain in the computer and other ways of working with computing. So we were trying to synchronize the whole thing together, and we're continuing to work on this. I think it's got really good potential because you can synchronize, and I think sound is really the key, because when I ask people to start sounding like or something together and they get in sync, the brain waves also get in sync and the color gets in sync. Next person is Siddharth Ramakrishnan, who was a postdoc in neurosciences when I came, at UCLA. And we started working on a series of projects together. He's a brilliant scientist. He went from postdoc at UCLA to postdoc in Columbia University in New York, and I happened to be in New York at the same time, so we continued working. And now he's in Seattle and Puget Sound. He got his own lab, and he's doing art science projects. So he's kind of proof that your career won't suffer if you work with artists. In fact, it's like a fear of a lot of young scientists, like, oh my God, how am I going to be perceived? So our first project was the dog sniffing game, because he worked a lot with smell, and particularly how smell is related to your mind, to your consciousness, and to your hormones, because it's actually the first sense that's formed in you when you're embryo. No, I took this picture of a dog that this picture was from Ireland, a dog in Ireland, amazing guy. It looks like a brain, right? I mean, it totally looks like a brain. So we started doing these series of projects of dog noses and then looking at what dogs can smell that humans can't. It's incredible what they can smell. They can smell 2 weeks into the past. They can, in 2 weeks ago something happened here, they can smell it. They can smell on a molecular level, incredible. No machine can come close to what the dogs can do. And now there's even a lab